Welcome back, favorite sixth graders. We're going to be getting pretty distinguished today. Going to do division involving a fraction and a decimal. So this is the very, very, very distinguished level of this dividing fraction skill. Is what if one of the fractions isn't a fraction? So we're going to be upping your distinguished game today. Please make this the title on the next free page in your math notebook, and when you are all set, put that aside and unpause and concentrate until we get to redo. So a couple reminders you're going to need for this to cover before we get started. So first, let me remind you of our dividing fractions algorithm. We learned two ways to do that. The quicker of the two, which I'm going to be using today, is the algorithm. So if I were to divide 3/8 divided by, I don't know why I'm thinking so hard, mixing it up, by 2/5. Our algorithm for that was multiply by the reciprocal of the second fraction. So what we would do, we kept this one the same, but rather than dividing it by anything, we multiplied it by the reciprocal of the second fraction, which is simply exchanging the numerator and the denominator. And the reason we did that, now it's nice and easy to multiply. 3 times 5 on my numerators is 15. 8 times 2 on my denominators is 16. And so 3/8 divided by 2/5. You can't quite make one group. You can make 15/16 of a group. 2/5 is a little bigger than 3/8, so you can't even make one whole group out of it. So that's the dividing fractions algorithm. I'm going to need that. Other thing we need to do, representing fractions and decimals, may have been a while, may have been a year, may have been 2 years since you thought of this, and so I need to remind you how that works. So when you see a decimal, a couple of things to know. So that's a number with a decimal in it, right? First thing you need to know is your place values. When you go after the decimal, the first digit after the decimal is in the tenths place, and the second digit after the decimal is in the hundredths place, and then thousandths place and 10,000ths place, and so on from there. So if you know the names of those places, decimals are easy to turn into fractions, and that's what's going to need to happen. So if we look at something like this, we just look at a, let me give it a number in front. Let's do that. So if we look at that, and you know that that's in the tenths place, we would say that that is 3 7/10. So if you can say it, you can write as a fraction. So this is 3 7/10, because I stop in the tenths place. So writing that as a fraction works the same way. 3 7/10. Those are equivalent things. This is 3 7/10. This is 3 7/10. If you can say it, you can write it. If we go out 2 spots after the decimal, now I finish in the hundredths place. And we would say this as 4 16 hundredths. That's the last place. 4 16 hundredths. So again, if you can say it, you can write it. 4 16 hundredths. So that's how you write that as a fraction. We're going to be using that skill in the lesson today. So I wanted to remind you of that. It may have been a long time since you did that. So here we go. So this is what a distinguished fourth grader should not only be able to divide fractions, but do this division when there is one decimal and one fraction in the problem. So here's an example. What is 65 hundredths divided by 4 1/2? I couldn't write it out like that with my typing. 65 hundredths divided by 4 1/2. Well, I'm going to start by making a quick estimate. This is less than 1. This is much more than 1. I'm not even going to make a whole group. This is going to be really small, right? I'm going to take this already fairly small number and divide it into 4 1/2 groups. They're going to be quite small. So that's the first thing to notice, is I'm taking a small thing and dividing it up even smaller. So this is not something I know how to do with the skills that I have. just not. But I would be able to do it if these were both fractions rather than one of them being a decimal, and they can be. So if I can look at this number and say it, I can write it as a fraction. This goes out to the hundredths place. So this is the number 65 hundredths. So I can say 65 hundredths as a decimal, or I can say 65 hundredths as a fraction. Those are the same thing. So while this would be hard to do, this is still going to be hard to do, but not impossible, because now they're both fractions and I can do my division. 4.5 involves a mixed number, so I'm going to need to go ahead and turn that into a improper fraction. So 4.5 is 4 is going to be 8 halves. 2 halves makes 1, 4 halves makes 2, 6 halves makes 3, 8 halves makes 4. And then the other half will give me a ninth. So really the problem I'm going to do is 65 divided by 65 100ths divided by 9 halves. That's the same as 4.5. 65 hundredths divided by 9 halves. Told you this was going to be distinguished. But it all makes sense, right? We haven't done anything really that you've not learned how to do before. Alright, so now I'm ready for my algorithm. My algorithm says to multiply by the reciprocal of the second fraction. So I'm going to multiply by 2/9 rather than dividing by 9 halves. And I'm going to have some work to do here. This isn't going to be easy multiplication, but I can do it. So 65 times 2 is going to be my numerator. Got to figure that out first. 65 times 2. 2 times 5 is 10. 2 times 6 is 12. Plus that makes 13. 130. So my numerator is 130. And my denominator is 900. 130 900ths. Not the most beautiful fraction I've ever seen, but it makes sense. Because if I go back up here, I was expecting something very small, right? I took this already small thing and divided it into 4.5 parts, and boy, did I get something small. If you wanted to divide, reduce this fraction, you could divide your numerator and your denominator by 10 and get 13/90ths. Same thing, very small amount. So it makes sense. So when I go back and check against my estimate, it makes sense. So lots of steps, but all the steps make sense. They're all things you've learned how to do before. It's just kind of putting a whole lot together in a very distinguished way. All right, open up your math notebook. Let's try one together. What is 2 32 hundredths divided by 1/2? Alright, so I can get an estimate here too. I love to get an estimate before I do things sometimes, especially when it's a problem I'm comfortable with, so that I know I'm going to be close. So if I take this and 2 and a little bit and divide it into groups of 1/2, well, I'm going to get 2 groups of 1/2 are going to make 1. Right, so to get 1, I can do 1/2 once, 1/2 twice. I'm going to go up to 2. I can do 1/2 again and again. So I'm going to be able to make 4 groups to get to 2. I can't make another group. This is less than 1/2, so less than a group. So I'm looking, looks like I'm going to have 4 and a part is kind of the answer I'm looking for when I'm all done. So I can make 4 whole groups of 1/2, I think, and then a part of the group. So let's see. So 2 32 hundredths divided by 1/2. First thing I'm going to need to do is make this into a fraction. So if you can say it, you can write it. So that is 2 32 hundredths, which is 2 32 hundredths. So that's the same number written as a fraction, 2 32 hundredths. Divided by 1/2. Still not ready to do the division because I've got a mixed number here. We have learned what to do when there's a whole number involved. So, this is going to be a lot. So, 100 100ths makes 1, which means 200 100ths makes 2. So look, I'm going to turn this into 232 hundredths divided by a half. All right, now I'm ready for the algorithm. It's not the simplest fraction I'm ever going to multiply, but hey, I can do it. So my algorithm tells me to multiply by the reciprocal of the second fraction. So I set that up first, multiply by the reciprocal of the second fraction, and then I just keep the first one as it was. Let me start again. 232 out of 100 times, oh, this won't be so bad, times 2 over 1. So let's start with my numerator. 232 times 2. 2 times 2 is 4, 3 times 2 is 6, 2 times 2 is 4. That's going to be 464 1/100ths. And I could probably do some reducing there. I could certainly divide them both by 2, probably both by 4, but in this case, especially being short on time, I'm going to leave it here for now. If you were to change this to a mixed number, right, every 100 will make a whole. So it would end up with 4 wholes and 64 hundredths left. And I only did that to check it, because look what I expected my answer to be when I started, 4 and apart, and certainly we got 4 groups and apart. So that's how you do it. Change the decimal to a fraction, then use your algorithm. It all works out. It's a lot of steps. If this was a lot, I understand. This is a very distinguished skill. This gets you to the very top level on this standard in math, and I hope that it stretched your brain a little bit. If it was totally confusing, I recommend going back and checking out the I do or the we do again now that you've seen more examples. That usually helps it stick in your head a little bit better. But once you feel like you have a solid, distinguished grasp on this, and you've got a good example in your notes, you're all set. See you soon.